Hello, my name is Benjamin Lowery and I'm doing my project on SQL injection attacks. So what is a SQL database? There are a couple of different types of databases, but the most common is structured query language or SQL. It's a type of database that was developed in the 70s, and all the major relational database products such as Oracle, Microsoft SQL, and MySQL, they're all going to be supporting it. They all have support for it. SQL or structured queries work by creating a series of queries using keywords. So you have keywords here such as insert, select, update, delete. There are many more, but these are the main ones. And then you'll string these together in order to create a query, kind of like the one shown here, which is just going to go and check for an ID from the user. Now, what is a SQL injection attack? A SQL injection attack is it's a type of cyber attack that attempts to use a database's code in order to allow an unauthorized user to manipulate the data. It's looking for a vulnerability in the code that allows someone to just peek in behind the wall and see what you have back there. So when we talk about manipulating the data, we're specifically talking about reading, deleting, or rewriting the data that's stored on the backside. This is usually done by taking a legitimate snippet of code and then just playing pin the tail on the donkey and adding a tiny little snippet to the end of it that changes the code's meaning. How does it actually work? Well, we're going to assume that we have a web page linked to a database to provide validation. This is a pretty common setup. There are a million web pages out there that do this, and it's quite possible that the login credentials, the username and passwords that you provided when you registered, are stored in a SQL database on the backside of a server somewhere. So when you navigate to a web page and you put in your username and password, the web application is just going to take those and run off and check it back to what you have already provided in the database. This is how it validates that you are who you say you are. It uses a statement a lot like this one shown here to the left. If it finds a match, you're going to be forwarded to a members page or given access to wherever you were supposed to go. If it doesn't, you're going to be redirected to a denial page or given an error message. On the right here, you can see just a very vanilla login bar with two text boxes. What if instead of entering their password, an attacker were to enter something like drop table users as shown here? Notice that there's a single apostrophe at the front and then two semicolons and a double dash at the back, which is a comment bar. What happens is if he entered that in the password tab, the web application would actually go ahead and just try to run it. And since it's got that single quotation mark or single apostrophe at the front, it's actually just going to use that to close one of the open apostrophes and go ahead and make that syntax into a viable SQL query as shown below. So you'll have it where it's going to be select from users where username is Joe and the password is anything, and then drop table users. So what happened here is Joe or whoever just deleted the entire table from the database using that code. So what does that mean for us? Well, there are a variety of concerns for an attack like this, but the biggest one is what if instead of deleting data, the attacker were to actually just change it or better yet steal it. Now you can see here from the CIA triad, the three main pillars are availability, confidentiality, and integrity, and we've all learned that. But a SQL injection can actually be used to attack all three of these. You can delete it and have the loss of availability. You can actually change it or alter it and have the loss of integrity. And sure enough, once you get behind the curtain and can see behind it, if you're clever and a little bit lucky, you can sure enough steal just tremendous amounts of data from it. Besides the more obvious addition of like new users or changing something like a salary or passwords or things like that, it's possible to just add commands or other data to tables that will help facilitate a future attack. For example, if you look at the code shown here, a table containing usernames and salesperson data is updated with an HTML redirect to pull a script from an outside site. Now, this code requires that the table he updates is viewed by a user or is pulled by somebody, but this is not that uncommon. For example, in this specific code block, all it would require is that the site need to greet you with your name when you log in or something of that nature. Anytime you're going to pull a first name and last name from the salesperson table, it's going to add the script, the JavaScript's piece there that's going to actually go to and pull a JavaScript plugin from another site. And this could be anything. It could be a keylogger, it could be a drive-by downloader, it could be a cookie downloader. It could easily be any malware, and it's an easy way to deliver it. And then finally, the most dangerous outcome of a SQL injection attack is the loss of confidential data. This can be devastating to small businesses, or really any business, and consumers as well, since it can include everything from medical records to credit card numbers and passwords for sites. It can take anything that a company has, any information a company has on consumers can be stolen in this way. Commercial businesses are particularly vulnerable because they're constantly under attack by hackers for this. Now, the classic way of attacking a user login just involves adding or when 1 equals 1 without the second apostrophe, which when you look at it, if your SQL statement is coded like this, it's going to be select anything from users, any place from users where username Joe and password is, blah blah blah, or 1 equals 1. Well, 1 equals 1 is always true. It's a true statement, and so it's going to always return the data for that slot. So every time it compares data, it's going to return it. So it's going to return the entire table, because every time it goes in and checks a line, it's going to reach the end and say, oh, 1 equals 1, and it's going to return that information. So you're going to, by using this statement, you will gain the entire table if it works. Now, obviously you have to know the name of the table, but you can usually guess some of those. People don't disguise them clearly enough, and so by guessing stuff like user, users, salespeople, stuff like that, you'll be able to guess the actual tables. So how can you prevent an SQL attack? There are several methods to do it, but the main two ways are validating user input and coding or setting sufficient permissions, creating blocks between different layers. And so a good defense is actually going to combine both of these and create layers of security to try to keep attackers out. It's also a good idea to patch your weaknesses and just know where you are weak so that you can develop strategies to counter that. One way to block the SQL attack is to validate input. Block obvious syntax from the SQL compiler. So, for example, you could block all single quotes from being delivered to a query. The method to do this is to actually convert any single apostrophe to a double apostrophe, two singles, excuse me. And what this does is anytime you have a single apostrophe, it's going to actually create two. So what that's going to be is an open and a close. For example, if you look at where we were looking at just a second ago, the previous example, you're going to see that it no longer works, because now instead of it having a missing apostrophe, instead of having an odd number of apostrophes, it actually has even, because instead of having 3, it's going to have 6, and that's going to actually prevent it from being a problem. So it's actually going to, so the compiler is going to go in and it's going to search for any password that is XXX or 1 equals 1. It's going to just go ahead and discount every place that there's two single apostrophes there. Other things you can use are blacklists and whitelists. Blacklists are lists that check for known bad values. For example, 1 equals 1. Now, blacklists are less useful than whitelists because there are a myriad of different things that a blacklist would have to check for. For example, just true statements. Well, that could be 1 equals 1, or 2 equals 2, or 3 equals 3, or 1 is less than 2, or 4 is greater than 2, or any of those. Those are all true statements. Whitelists are more effective, but they include patterns for known good values. And then another way you can prevent inputs that are faulty is that you actually take any decimal input and you convert it immediately to the type of data it's going to be used as. So what that would mean is that if you had a box for, say, a phone number, it doesn't accept a syntax input, it only accepts numerical, and it immediately converts it into, say, a decimal or an integer value before it even goes to the SQL database in the table. And then the last thing you can do is actually set your permissions. Now, this is very important because if a web application or user isn't supposed to be able to read from or update a certain table, you need to go ahead and block it. You can set certain tables and actions away from certain roles, and you should build those roles and go ahead and maintain them in order to create a layered defense. As you can see here, this is just a basic table of priorities and not priorities, but permissions as you go up. So the administrative user is going to have the most permissions, and then as you branch out, you're going to have greater roles. And what you want to do is have them set up so that if you are attacked and if the person does manage to gain some control, they can't get everything. And so there are going to be areas that they're locked out of just because they're not connected. And then the last thing you need to look at is patching your weaknesses. So there are some things that you can do to mitigate an SQL attack, and there are other things that if you haven't done them, you're inviting a SQL attack. So a lack of segregation of tables and servers, that's a real easy way to make yourself a really tempting target. So you want to go ahead and divide them up as much as you can. Some other things are inconsistencies in database construction. I mean, when you build them, if you wait a few years and build some more, versioning, another thing, anytime there's a compatibility error, there could be a very serious problem. Do your patching, stay up to date on it, and then another thing that I found interesting was several places pointed out you don't want to have detailed error messages. You want to make those as cryptic as you can in order to prevent giving away information freely to the attacker. These are my references, and hope you all have a great day.